Hey folks, how's it going? I was just trying to decipher the keyboard encoder on this thing for the purposes of interfacing the Apple II keyboard to the contraption, that being the Raspberry Pi card that I'm trying to hack together for this thing. That right there is the keyboard encoder chip, and that is the keyboard connector. And what I was first thinking about was just making something that sat in between the keyboard connector and the keyboard cable, that would be able to pass through and disable the signals to the 2E motherboard, so that input can be cut off when it's in ARM mode. And then simultaneously output, this is the chip I'm going to use for it right here, but simultaneously output USB keyboard key up and down events and stuff out the USB port on that thing and into the contraption. But so I was trying to decipher how this chip works. Here's the data sheet for it up here, and these kind of keyboard encoders, well, I've got a schematic for the Apple II here somewhere. I think it's got a paper in it that's better than that one, for probably the one in the back. Sorry, I'm not very prepared. Alright, I'll get up there. So, the keyboards usually work like this. They call these matrix keyboards, and you see there's a line of rows, there's a set of rows that come into the keyboard, and a set of columns that come into the keyboard. And the switches on the keyboard are arranged, my crappy old phone won't focus, but the switches on the keyboard are arranged in a matrix like this, so that when you push down a key, it connects a certain column with a certain row. And the way these keyboard encoders generally work is they'll say set either all of the rows or all of the columns high to a positive 5 volts. I don't know which this one does. That's what I'm trying to figure out. And then there'll be a pull-up resistor, and when you and these will be inputs here, or these, depending on which one's pulled high by the keyboard encoder chip. And then one by one, it'll pull each of these low, and when you hit a key, there'll be an input out here and a pull-up resistor, and then this row will tie into it. And when you hit a key whose column is enabled, it'll pull that input low through the key switch. Clear as mud, I'm sure. But my problem was I didn't know whether the columns or the rows were the inputs on this thing, because the data sheet doesn't seem to specify. So I'd hooked this crappy old oscilloscope of mine up to the keyboard encoder chip here. I bought this scope at a Hamfest in 1998 for $15, and it just barely works, but I guess it gets the job done. So right now I've got it hooked to the X0 input, or output actually, and that's, well, I'll show you on the schematic later. And we can see it's actually, this keyboard encoder doesn't work exactly like I thought it was. It's strobing high as it scans that column, and you can see a little bit of ripple down here. I'm sorry, the intensity control on this scope is messed up, and I can't turn it down to where you can see it. It's way too bright. But you can see all the little ripples where it's scanning all of the other columns as well. So I'm pretty sure that the X set are the enables for the key matrix, and then the Y's will be the inputs. So let's see if I can zoom in on this a little bit. There you can see the wrong way. There's the pulse where it reads the keyboard. Anyway, I'm just kind of pooing at the mouth here talking about stuff. So yeah, anyway, originally I was thinking about just building something that sat on a little card that would plug into the keyboard connector, and then the keyboard would plug into it, and it would have that microcontroller board on it, and it would just, you know, do all its stuff through there. But I was talking to a dude on a forum, and I think it would be way easier to just build a board that plugs into the keyboard encoder socket and then emulate the outputs of the keyboard encoder. I mean the binary output that the rest of the computer actually reads, not the keyboard scanning stuff. I think it would be easier to emulate that in software on the microcontroller, and then just write my own code to scan the keyboard and stuff, which I would have had to have done anyway. And then I won't have any timing issues, which I would have had if I were trying to, you know, work with the scanning side of things on the keyboard encoder. So that's going to require plugging into both the keyboard encoder chip socket and the keyboard socket, and I don't know if I can make something on protoboard that'll do that or not. I guess I'll have to have a piece of ribbon cable, and I can probably make something on protoboard that'll plug into the socket there. So yeah, the problem with only using the keyboard encoder chip socket is, here's the keyboard encoder chip on the schematic diagram of the Apple II, and all of this stuff here is the keyboard connector. And you can see that there are some lines here that don't go through the keyboard encoder chip. Right, so those have to be handled differently. The caps lock key and let's see here. The open Apple and closed Apple keys I don't think go through it, because they're actually part of the game controller. Yeah, they're up here. And in order to read the reset key separately, I'm going to have to disconnect it from here and reconnect it to the ground over here. And then the microcontroller will be able to read it separately. And then when I press Control Reset, the microcontroller will pick it up and pull these lines low. And that'll emulate the key presses through the microcontroller. Now, another thing that I'm going to have to do in order to read multiple keys being held down, which the Apple II doesn't support. The keyboard encoder chip that the Apple II uses, according to the datasheet, actually does support in-key rollover, but they don't have it enabled for the Apple II. And thus, it's not wired in the Apple II in such a way to make that possible. But the problem is the keyboard doesn't have any blocking diodes in it. And what happens is when you don't have those blocking diodes, if you hold down multiple keys, it creates multiple paths for the current to take through this key matrix, and you end up with ghosted keys. Like if you hold down two keys in the same column and push one, and two side-by-side columns and push down one on top of it, the one up here will ghost as well and appear to be pressed even though it's not. And the way that you fix that is you put a little blocking diode on one leg of each of the key switches to keep the current from flowing back through the switch backwards. And in order to do that, I'll have to take the keyboard out, and so I can flip it over and get to the circuit board on the back. And on one leg of each of these switches, I'll have to actually cut through the trace on the circuit board, and then solder the blocking diode from the switch leg where I've cut the trace off to the other side of where I've cut the trace on every key. So that will be a pain in the butt. But since we've figured out which of the X and Y pins on the keyboard encoder are the ones that are getting, well, set high, I ought to be able to arrange the diodes in an orientation and design the circuit for the microcontroller in such a way that if I unplug the expansion board thing and plug the keyboard back in, it'll still work even though it's been modified. So I'll have to think about that a little bit. Quite frankly, I'm too tired to process that right now, so I'll work on that some other night. Alright, cool. See you later.